Okay, now I gotta mute that one. Okay, good. Okay. So let's start going over 3.1. Are there any questions from chapter 1 and 2 before we get started?
No.
No, it was pretty straightforward, wasn't it, Lori? It wasn't a big deal. Um, chapter 3, though, we actually get into some actual math, which is nice. And chapter or 3.1 is over measures of center. And we know the main measures of center, hopefully by now. The mean, median, mode, right?
Mm-hmm.
Mean, median, and then mode. And we're going to stick to, at first, we're going to talk about the mean. The main thing about the mean, of course, is you just add up all the numbers and divide by the total. We know how to find a mean and the average. We are going to talk about a little bit about the how to notate it, because it's notated differently with the sample and with the population. With the sample, we write it as X bar, okay? This means sample mean. And then mu looks like that. And you can see on page 95, it's in the middle of page 95, how it looks whenever you use, like a computer to write it. But mu is the population mean. Okay. And it's very straightforward. We just add everything up. We divide it by the number. Not a big deal. Little n is going to be the sample size. If we're dealing with the sample, capital N is the population size, if we're dealing with a population. Okay, so little n goes with sample, and then big N goes with population. And you can see the little equation they gave there. I'm going to pop this off real fast. Hold on. And let's do another picture. Because we're going to see a lot of this going forward. So like if I wanted to get, let's say, the average on a test, and let's say the first test for one of my classes was like, 60, 75, 77, 80, and 90. And I'm going to consider this a population because it's an entire class. Well, if it's an entire class and it's a population, I would use mu, and I would just add all these up and divide it by n. Now, the way you notate that is with sigma. Sigma means the sum. So I'm going to add up all the x values and then divide them by the population. That's what this means. And you can see that. I bet it's on the same page. Yeah. I use x sub I because that notates x of x1, x2, x3, x4, x5. Excuse me. So we can add all these up. 60 plus 75 plus 77 plus 80 plus 90. And then we just all divide them by 1, 2, 3, 4, 5. Not a big deal. Now I'm going to show you how to do this on the calculator. Okay. So I'm going to go slow this first time, and I'll probably mess up because I haven't used it in a little bit, but I'm going to do my best to not mess up. So first off, we have to make a list. This is going to be the list we have to make. And to make a list in these things, I believe you actually have to go to stat. So if you click on stat, and now if you have the actual TI, it'll have the same options, but you want to go to the edit option right there. Boom. You'll see stat edit. And you'll have these different lists, L1, L2, L3. We're just going to use L1 as our list. And you put in the number and then hit enter. So the first number is 60. And I hit enter and it put in 60. I know it's hard to see there. Then 75, it doesn't get any easier. The lighting's all messed up for this actually, because we have crappy lighting here. And then I'm going to put in 75, enter, 77, enter, 80, enter, and then 90, enter. Okay. Now I'm not going to put anything in that last cell. Really, it's like an Excel cell in a way. I'm going to quit from here. So from here, I'm going to quit completely. So if you hit the second mode button, you'll quit. So second mode. And what it does is we've made this L1. Okay, that's our list for L1. And to get a lot of statistics, we're going to use the one variable stat that's already in your calculator. It's going to give us a lot of things. But one of the things it will give us is the mean, which is what we're going over first. So to get to one variable stat, we go back to statistics, okay? And instead of edit, because we already have our list in there, we're going to do calc. And notice the very first option is one variable stats. Now, Lori, are you doing this on the TI 83 or 84?
Yeah, I got the TI 84 plus.
Okay, is the calc, when you hit stat calc, is the first option one var stats?
Yes.
Okay, perfect. So click on that. And then you're going to have to call a list. So to call the list, you have to hit second stat because that'll bring up the list options. So hit second stat. And we want list one because remember we made list one. Close parentheses. Oh, shoot. Oh, no. How do I backspace? There it is. And then hit enter. And you'll see now on the calculator, you go up or down over here. But you'll see that it gives you a lot of these things we're going to go over here in a minute and what they mean over today's lecture. But the very top thing it gives you is the mean. And I believe in the calculator, it actually says X bar, right? Does it show you X bar in the calculator?
I'm stuck on the closed parentheses.
Yeah, the close parentheses is above the 9. And then hit enter.
Yeah, I got to go back.
But what's nice is it gives us the mean. So for us, since we did a population, we're going to say this is mu equals 76.4. Okay? Mu equals 76.4. Okay?
Calc, enter, parenthesis. Okay, I just messed my computer up.
Well, that's fine. And when we do the next one, I'll write all this down just because now that I know, I did remember how to do it. Nice.
Calc.
Okay, the median will be given in there too. So if we go to the median now, the median doesn't have a cool symbol. We'll use like capital M. How about that? We'll call that the median. Now for us, the median is 77. Because it's the middle number, right? If we had another number, you would just average those two together. We'll do one in a minute with an even amount of sample size or population size to show you how to calculate the median. That's not a big deal, okay? But what's nice is this calculator just craps it out real fast, so we don't have to do anything by hand. So if we have like a jumble of scores that's not in order, it'll automatically bring out the median or bring out the mean, and we're good to go. And it gives you the max and the min, which is nice for the next section and all that fun stuff. Okay, so I'm going to pause here, not pause, but I'm going to talk just a minute about what's important about the mean and median and why they're different. So the mean is very, very particular when it comes to large or small numbers. It can really change if we threw a very, very large or very, very small number into the mix. Where a median is what it's called resistance. Median is more resistant to change as compared to the mean. For instance, let's go in here and let's say that I forgot to put a grade in and someone made a 5. So now we've got a 5, 60, 75, 77, 80, and 90, okay? Excuse me. So if I go back in here, I'm going to go back to stat. I'm going to go back to edit, and I want to edit the list. So here's my list, right? Here's list 1, and I'm going to go down and I'm going to add one more test. Someone took the test, bombed it, and made a 5 on it, right? They got their name right, and that was it. So now I'm going to hit enter. So I've got one more. So now I have a population of 6, right? Instead of 5. Now, look, I'll tell you, my median now is going to be 76 because you take the average of the middle two numbers. But let's do that again. So now I'm going to go back through. I'm going to go to second stat. Oh, actually, no. Let me get out of here. And I'm going to go to stat. And I'm going to go to calc one variable stats, L1, and we'll see that my mean now has changed to 64.5. Holy cow. So one bad grade jumped my average by over 12 points, right? My average dipped from a 76 to a 64 based on one single low test score, okay? But now if we look at the median though, the median we know is the average of these two, right? The median is going to be 76. It didn't move much at all. It went from a 77 to a 76. This is called resistance. The median does not have much resistance, right? It doesn't change that much. But then the mean though has a lot of, I mean, actually, wait, hold on. Let's his resistance if its value is not affected by it. So yeah, the median has a lot of resistance because it's not affected by outliers. Okay. So mean can be very picky about this. Now, of course, if we increase the size of our sample by like 1,000 or something, and then we have one really small number, it's not going to move the mean that much, right? But that's one way to change. One way to kind of increase the resistance is by increasing the sample size. But if we have a small sample size and we include one more data point, it can really mess up the mean. Okay, it has very low resistance. That's what that's trying to say. Okay, your book then goes over, this is on page 98, 99. It goes over skewing again, which we talked a little bit about in a previous lecture, but it talks about the skewing of the median and the mean. Okay, and then if, here, I'm gonna just kind of draw this. So we have two types of skewing. We've got left and the right skew. We talked about this already. But what's happening when we have a data set like this, like let's say this is not like the test we just had. This is like, let's say we had a test where everybody scored around like the 50s, but then we had a few that scored in the 90s and 100. This is what this kind of graph would detail. The median then is going to go left of the mean. So the median's about there. The mean would be somewhere here, right? Remember, we called this skewed right. This is skewed right, and it's because the mean is to the right of the median. Where the flip side, like the example we just did, would have a skewed left, right? Like if we think of this data we just did, the median stayed about 76, right? But the is somewhere in here. When it went a lot lower, 64.5. So this would be skewed left data. Okay, this would be skewed left data. Now I'll tell you, the original example we had though, these are really close. I mean, it's only off by like a point, right? Really half a point. So these are really close. This is nice symmetric data. So symmetric data, which I'll kind of toss under here, is when the mean and the median line up. That's what we want, that nice bell curve, right? It's when the mean and the median both line up in about the same spot. Okay, and when the mean and the median line up in the same spot, you have this nice bell curve. Okay, and yeah, your book calls it approximately symmetric. Okay. And of course, mode is just the most. Okay, and I'm going to read what the book says. The mode says the mode of a data set is just the value that appears the most frequent. If two or more values are tied for the most frequent, they are all considered to be the mode. Sometimes you'll hear the word like bimodal. It means we have two modes, but you can have as many modes as you want. But if there's no repeating values, we would just say it doesn't have a mode. Okay, that's what the last summary statement says. If the values all have the same frequency, we say that the data set has no mode. Okay, so very straightforward, not a big deal. Yeah, and I don't think the calculator does mode. You'll have to just look in the data set for mode. Okay, and then on page 102, it goes over the weighted mean. Okay, so if we wanted to find the weighted mean, which you wouldn't really use a calculator, the calculator just pops out the mean anyway. The weighted mean happens when you kind of have a lot of data that's repeated. Okay, so if I had, and it's really kind of basic, and it's basic understanding of an idea. Like let's say I did give tests again, but we had a lot of repeating values. Let's say we had like, we had 4 people make 85s. We had 2 people make 90s. We had 3 people make 72s for some reason. Okay. And then we had 1 person make 100. The weighted mean is really just beneficial if you're doing this by hand. If you're doing it in a calculator, it doesn't matter. You get it in the same amount of time. But the weighted mean says, hey, we've got 4 people that made 85. So I'm going to just multiply that by 4 instead of writing out as 85 plus 85 plus 85 plus 85. Plus 2 people that made 90. So instead of writing out as 90 plus 90. Plus 3 people that made 72. Plus, you can write it as 1 person made 100, but we know that you don't have to write that 1 there, right? And then the total would just be these added together, 4 plus 2 plus 3 plus 1. So that winds up being what, 6, 10? Is that right? 10, 4, 6, 4,
Yep.
yeah, 10. So divided by 10. And then you can do it in the calculator that way. Okay, let's see, I'm just going to do it over here on the calculator. 5 times 85, or 4 times 85. Plus 2 times 90, plus 3 times 72, plus 100. So I got 836 in the numerator. Divided by 10 gives me 83.6. So the average, now that's just the average. If this was a population, it would be the mean, right? But it's considered weighted mean because instead of adding these all up individually, and then dividing by 10, you grouped them together. You weighted them together, okay? And you can see, what's nice is visually you can see that this 85 kind of weighs the most, right? Because it's got 4 people that have an 85, or the 100 weighs the least. And notice it's kind of close to 85. That's not really a coincidence, okay? Now, of course, if we had a lot of people in here that made like zeros, it would skew this data. But that's how you find the weighted mean. Your book kind of has the definition there, and you're more than welcome to look at it. I don't mind if you know that it's not going to come in handy at any point, but it is in the book. Okay, for 104, page 104, let's look at the homework for 3.1. And actually, the homework starts, because your book does this thing where it gives homework throughout. Well, where's number 8? Hold on. So it starts on page 99, actually. Page 99. I want you to do 1 through 7 there. And then number 8's on page, I think the next page, on 101. Number 8. And then page 104 starts like the actual homework in the back of the section. Hmm.
1 through 7.
I'm not worried about 25 through 28. Let's do 9 through 20. 9 through 20. Graphs, that's not that big of a deal. And then let's look at some of this other stuff for homework. And now, if you're getting it, it's not a big deal. So I want you to look at 36, just kind of word problem stuff. Actually, I will say, like, algebra compared to stats, the word problems are typically more fun because they're more relatable. Number 40. And then let's do 41. And then let's do another odd one. Oh, hey, flu season. That's a perfect. Yeah. Let's do 45. So do that for 3.1. So it's in there. You guys can go back and look at it if you need to write it down. A lot of examples in here. It's good. Yeah. If you want to look at other examples, you're more than welcome to. But that kind of gets the basics of what we're going to be doing with mean, median, mode. the main thing about mean, median, mode is one, your calculator can calculate it. So I'm not going to sit here and just do the math a lot for it. But understand that these are all about the center. And really the mode I'm not worried about as much, but the median and the mean, we need to line up pretty evenly for us to be able to use some statistics, some like larger statistics that we have in future sections. The mean and the median have to line up for that to work out. Okay. Okay, let's go on to 3.2. I think range, and actually I think most statisticians would tell you this, or not range, but the measure of the spread really is more important for what we do in, actually I'm going to raise this up a little bit so I can get the whole paper in. Okay, there we go. The spread of the distribution really tells you more about the entire population than the mean. And I'm going to give you an example, a basic example here in a second. Let's say now I'm making these numbers up, so it's kind of hard sometimes to do this. But let's say I gave a test. We've got class A and we've got class B. Okay, I give them both the same test. In class A, the grades are 75, 75, I don't know why I wrote a 7, 75, 76, 76, 77, 77, 77. Okay, that's 1, 2, 3, 4, 5, 6, 7, 8. We have 8 students and all their grades are right here. Okay, class B though, same test, but I've got, let's say I've got a 49, I've got a 55, I've got a 72. Hold on a second. Clear this out. Let's say I've got an 80. Let's clear. And I've got a 90. One, two, three, four, 5. And I've got a 95. Six. And let's say I've got a 97. Okay, yeah. So we've got these two classes, and we've got really 2 completely different scores, right? I mean, this class has what we call the very tight range. Your range is the very first thing your book talks about. Range is just the maximum minus the minimum, okay? So if I wanted to look at scores ranges or a class's range, it's the very basic measure of spread, the most basic measure of spread. You just take the top score minus the bottom score. So 77 minus 75, we wind up with 2, right? The range of this bottom score, though, is 97 minus 49. Yes, I am using a calculator, which is 48. This is a huge difference in the range, okay? But let's look at the means real fast. I'm going to consider these a population. The mean I know for this top one's going to be 76, okay, just because it's perfectly symmetric. The mean of the bottom one, I was kind of doing this as I was calculating it, is 76.9, okay, almost identical, right? So even though, like, imagine this, imagine I told you that we've got these 2 classes. Class A had an average of 76. Class B had an average of 76.9. You might think, and it would be wrong of you to think this based on that, is that these classes are the same, right? Because one class made a 76 and another class made a 76. They're the same. And this is a big issue we have in academics and education, because it kind of seems as though the needs for this class will be the same for the needs of this class, right? Which it's not true at all. If you're, imagine teaching, kind of putting yourself in this situation, right? If I get back these test scores, this class is going to be much harder to teach, right, than this class. I got this class all in the same spot, right? I got them all right in one little bucket, and I can kind of move them up because I know where they're at. This one, though, these students are going to be much different than these students to teach, right? Either these aren't, let's say they're all coming to class and doing the homework. They're trying hard, they're just not getting the concept. They're sleeping through probably and getting it, or they might be working their butt off to get it too, okay? But they're understanding the concept, right? So two totally different classrooms, they've got the same average, so the mean doesn't tell us that, right? And the median's probably pretty close too. The median up here is 76. The median down here would be what? 1, 2, 3, 4, 5, 6, 7. So it's the middle, 1, 2, 3, 80. So 76 and 80 is not too far off, okay? So the mean and median don't tell us much, but the range tells us the full story, okay? And I'm going to write this down because I think it's important. Measures of spread give us the entire, I'm not going to say it like that. Paint a better picture of the data set. That's a good way to put it. Measures of spread paint a better picture of the data set, okay? And we can see that quite clearly here. If all you knew were the measures of center, you're not going to think anything's different. The measure of spread, though, tells us, whoa, this range is 48 compared to 2. We got a tight class. We've got a class all over the place here, okay? So the very first, and so this kind of ties in, the very first way to calculate measure of spread is range that your book goes over. And then your book goes over variance. Now, variance is going to change if we have a population or if we have a sample, okay? And what's nice is I'm not going to calculate this by hand. If you've done it before, because I know some of you have had stats before in the past, you know it's kind of a pain in the butt, but I'm not worried about how to calculate variance. What I am worried about is you understanding what it is. So let's look at these and their symbols. So the population variance. Your book goes over this first. That's why I'm going over it first. Now we use sigma squared here. Now the way that looks is kind of like this, okay? That's sigma squared. And I'm going to write this equation down and kind of tell you what it's telling us, but I'm not going to actually do all the math because why when our calculator does it? Remember, I said sigma means the summation. So we're going to add all the differences from the average, and then we square them and we divide them by the total population, okay? So what this means is we actually are looking at the differences from each like score from the mean, and we square them up and then we divide them by n, okay? Not too worried about that. I don't think it'll pop up per se. And if you're like, man, I'm really intrigued by this, I want to know what he's talking about more, read the book, okay? It'll tell you exactly what I'm talking about. So really what we have in a way is an average of the squared variances from the mean, okay? So think of it like this. Think if we've got these data points, now I'm going to give you kind of a visual way to think about this. I've got these data points all vertically written. So let's say they're like, oh man, this is not a good way to do it. Hold on, let me think of a better way to do this. Because we haven't gone over that aspect. Oh, yeah, let's think of it on a number line. Let's look at a number line, and let's say the mean's right here. Let's say if we look in the back, like the mean is, for some test score is 76. So this is our mean, okay? And I'm only going to give a few of these on here just as an example. Let's say someone makes a 70, this would be what, 74? Okay, so someone makes a 74, they're right here. Well, we know the overall mean is 76. That difference right there is 2, right? It's really -2, right? Well, that's what that's what's right here. It's 74 minus 76, -2. Then we square it, so we get a 4. And then we add all the variances. So think if we had another one, some other guy made or gal made a 79, right? Their difference from the mean would be a +3, right? And then let's say someone else made like a 70 over here somewhere. Where's it? Now, if they made a 70, so this is a 70, their variance would be -6, right? Okay, and so on and so on. Now, I'm not going to do this for all of them, but that's what this is going over. It's squaring all of these and then getting their average because you divide it by n, okay? It's squaring all of those and getting their average. And it's a way to give us the range. Now, the reason why we use it is because it pops into other statistical measures we're going to use later on, okay? If you're wondering, well, why do we do that? Why do we square? This is goofy. Well, yeah, it is kind of goofy, but the reason we use it is because we're going to go on to like higher level statistics, and it uses this in the higher level statistics, okay? And it's in the TI calculator, which is even better. Like if we go back to this TI calculator, which you guys can kind of see that. So if I go back in here and I go back to stats and I go back to one variable statistics, and I'm going to use the same list, list 1, enter, you'll see, I think that's right. Oh man, we might have to do one of these by hand. Let's see if we can. Get this right. Oh, interesting. Oh no, we're gonna have to do one of these by hand just to see which one of these line up. Hold on. You should be able to find the variance in the calculator. Give me a second. I'm gonna Google this real fast. How to find population variance in TI-80, whatever. Oh, it doesn't find the variance automatically. That's a bummer. You have to square the standard deviation. Yeah. Okay, that's not a big deal. So what it does, okay, do you see that one symbol that looks like this in the calculator? It's, for me, it's right underneath the capital SX. That is our sigma. That's this guy right here, okay? So for that, it's what we at 28.040. We'll go to that length. So if I wanted my variance, my population variance, I just have to square that. So I have to do that by hand. That's a bummer, okay? So I'm gonna clear this out so I can quit. I wanna clear it up. There we go. Okay, so I'm gonna do 28.040 and then square it. And I wind up with my variance, my population variance for this data. 786.2416. So remember that was the test that had the like 5 on it, right? We had the 5 and then all the other numbers. We had a variance, a population variance of 786.2416. So to find it in the calculator, you use the same list mode. It gives you, this is called the standard deviation. It gives you the population standard deviation, and then you just square that to get the variance, which is true. The book just hadn't got there yet. So I'm going to write that down. Standard deviation. This is horrible. Hold on. Standard deviation. Squared is the variance, okay? And that's true for population or for the sample, okay? You square the standard deviation, you wind up with the variance. So in the calculator pops out the standard deviation. You just have to square it to get the variance. So not too weird, but it's a bummer it just doesn't do it for us. Okay. So anyway, back to this. So the population variance is just a way to measure spread, and it's given by this formula. We don't have to know too much, but it's the average of the differences squared divided by the population. Now, the sample variance is going to be different because we don't divide by n, a capital N, we divide by the degrees of freedom. So we have to talk about that for a minute. So let me park it right here for a second. We got to talk about degrees of freedom. So you'll see it in the equation here. Excuse me. The equation for variance, so variant, sample variance. Sample variance is written as S squared, okay? And it's because remember it was standard deviation squared, right? But it's equal to, the numerator looks very similar, right? The sum of each value minus the average, but remember average with sample is X bar squared, but instead of dividing it by n, you're going to divide it by the sample minus 1. And that denominator is called the degrees of freedom, okay? That denominator is called the degrees of freedom. So the degrees of freedom is actually, your book does a really good job on page 117 on going over it. And it's really goofy and kind of hard to explain. But the degrees of freedom is for an average, or for the standard deviation, is always just n minus 1. And it has to do with the fact that whatever last number you plug in really is stuck. All the numbers before it can be whatever they want to be. And I'm going to give you kind of an example. It's okay if this doesn't make sense. It's not going to pop up on the test per se. Now I might ask you, what is the degrees of freedom? And you just have to say it's n minus 1, right? So if our sample was 20, it would be 19, okay? But the reason it's like that is, let's say we were adding up getting an average of test scores. So we had like 65 plus 67 plus 70 plus, now I don't know what this test score is, but I know the average is 68, okay? This would be the average. What this is saying is these numbers can kind of be whatever they want to be. They're independent, okay? They can be whatever they want to be. This last number is what creates the average, because whenever we add that number to it, we actually get the average number. Okay, so let's just 65. Oop, that's not 65. 65 plus 70, or 67 plus 70. That's going to be 202. So we get 202 plus some number is going to give us an average of 60. Okay. Actually, we're going to divide that by n. Actually, by n, yeah, is going to give us 60. Okay. And we don't know the n value, right? The n value is going to be determined by how many people we have. So whatever that last number is, that has to be a dependent number. So because it's a dependent number, that means that our degrees of freedom is always n minus 1. And it's okay if that doesn't make sense. You can read the paragraph on page 117 that this goes over. But it's pretty goofy. But that's where the degrees of freedom comes from. It comes from the last number being stuck. Okay, and it'll pop up in other statistical measures we do throughout the semester, but that's exactly what it is. Okay, so let's go back to this stuff. Again, I'm not going to worry about you calculating this by hand. You're more than welcome to. It is right in our calculator. Okay, so if we go back to the 83, if we clear this all out and I do the one variable statistic again, so I go to stat, hit the wrong button, stat, calculate one variable statistic, and I bring up list 1 again, you'll see that it's going to give us the standard deviation. That S is the standard deviation. They call it SX. And for this example, it's 30.716. 716. So therefore, the sample variance is going to be that squared. So if I delete, quit, clear, 30.716 squared is going to give me 943.47. Now remember, this is the same data, right? We're using the same data and calling one a population and one a sample. But previously we found that the population variance was 786 while the sample variance was 943. And the reason is because we're dividing by, instead of, I think it was 7, we're dividing by 7 minus 1, which is 6, okay? You're dividing by a smaller number. That means you're going to get a greater number for the average, right? You're going to get a bigger number for the average. The number up top is going to be the same, but the bottom number is smaller, so therefore you get a bigger number. So not a big deal. Not that you have to memorize that, but the population variance will be smaller for the same data set. So we have to be careful and declare if this data is coming from a sample or if it's coming from a population, okay? Questions?
Yeah, can you hear me?
Yeah, what's up, bud?
This is Nathan McGee. My thing says West V. I'm on someone else's computer. I'm sorry I'm late. I woke up late. Did I miss an exam or anything?
Buddy, the schedule's on Blackboard. Have you watched the video?
Yeah, I've watched all the videos.
Okay,
It just says 3 today. I don't see a date that says exam.
Yeah, no, you haven't missed an exam. Hold on, let me check and see what you're talking about. Hold on, give me a second.
Yeah, on the schedule, all you have is the homework and the review.
Oh yeah, because we're having the test after the review. On the very first day, I talked about that in the introduction. The introduction went over that, or I think it did. If not, I'll go over right now. So if you notice the review day means the test is going to follow the review day. So that's where it comes from. So because your test is going to be on Blackboard, like you're not going to have a day off for the test per se. But then I'll pop the test in and I'll give you like 4 days to take the test.
Okay, sweet. Yeah, I've seen all the videos. I'm caught up. Watch it and I've done all the homework and everything. I just I was in a situation where I couldn't come live, and now I can do live, so I'll be here every time.
Great. Yeah. No, but that's what's going on. So after we get done with chapter 3, so next Monday, we'll have a review on. Oh, I'm sorry, you guys are Tuesday, Thursday. No, you're Monday, Wednesday. Yeah. So when we'll get done on Monday with chapter 3, we'll review for the test on Wednesday, and then I'll pop the test into Blackboard on Wednesday.
Okay, awesome.
Okay. Okay, so back to what we were talking about. So the sample variance is right there, not a big deal. But again, it tells us the spread. So let's look at 2 different data sets. So let's say I had a data set. Actually, let's go back to just smaller lists. So this will be a good way to practice if you can put this in the calculator. So I'm going to look at 2 different test scores again. Test scores are getting boring. Let's say we look at heights. Let's say I've got class A, and we'll do heights in inches. I have no idea. Let's say we get the average heights, or let's get the heights of just like 5 people, because I don't want to take forever putting it in the calculator. So the first heights we'll say are 54 inches, 56, 56, 57, and then like 62. Okay. So I'm going to find a few things from this. I want to find, we'll consider this a sample from class A. So we'll get the average, the mean, we're going to get the range, and we're going to get the samples. We're going to get the sample variance. Okay. So I'm going to go over to the calculator. I'm going to put these 1, 2, 3, 4, 5 data sets in. So let's clear this, go to list. Oh, wait, no, not list. I want to go to stat, edit, right? And I'm going to edit list 1. So edit, so stat, and then edit. And then notice I'm in list 1. I believe if you go up to the L1 and hit clear or delete, something like that. Press delete to clear the whole list. Okay, delete. I'm pressing delete. Hold on. There it is. Yeah. So if you go up to the very top and hit delete, it'll delete the whole list and we'll just kind of start over. So stat edit, and then I went into L1 because I'm going to make this list 1. And I'm going to make my other class here in a second list 2. So let's do list 1. So 54, enter, 56, enter, 56, enter, 57, enter, and 62. Okay. So I've got the first list. And let's go over to list 2 now. And I'm going to make the other class list 2. So we'll call it class B. Class B is going to list 2, and they're going to be drastically different, okay? So we'll do like someone that's like 49 inches, 56 inches, 60 inches, 62 inches, and then let's do, just to keep the 1, 2, 3, 4, 5 students the same. Let's say this last person is 64 inches. Why not? Okay. So if I go back in here, I'm going to go over to list 2 now, and I'm going to make this group. So I'm going to say 49, enter, 56, enter, 60, enter, 62. That's not a 72. That's 62, and then 64. Enter. Okay. So I've got my 2 lists here. No, it's there. We go. I've got my 2 lists going on, and I want to find the same thing for both of them. Okay. I'm going to find the X bar, the range, and the sample variance. So I'm going to go back now, second quit, and I'm going to go back in and do the one variable statistic for both. So remember, to do the one variable statistic, we're going to click on stat and then calc. And then the very first option is going to be one variable stats. And you've got to call list 1. I think it automatically puts list 1 in there, but I'm going to call list 1 because I'm going to have to call list 2 here in a minute. So to call list 1, we're going to have to do second stat list 1. And we'll see it gives us the mean, which is 57. I think it might give us the range. No, it gives us the max and min. The range is easy though, right? It's just going to be 62 minus 54. So the range is going to be what, 8? Now sigma is going, or sigma squared, which is our variance, is going to be 3 actually. That's crazy. You never see a nice whole number. So squared. So our sigma squared is going to be, our variance is going to be 9. Okay. So I know it's kind of hard to see right here. Look, I'll zoom in. No, it didn't work. The standard deviation is 3. So then if we square it, we're going to get the variance. I should say the sample standard deviation is 3. So when we square it, we get the variance of 9. Okay. So I pulled that data off of just one variable statistic. So I'm going to do the same thing, but I'm going to do it with my other group. So I'm going to find my sample mean. I'm going to find my range. And then I'm going to find my variance, my standard deviation squared. So I'm going to do the same thing. So I've got to bring up stat, one variable statistic. But then now I've got to bring in a different list. So I've got to bring in list 2, close it, hit enter, and we'll see this is going to be different, right? My mean, which is 58.2, that's not that different. My range is going to be 64 minus 49, so is that 15? So I've got a bigger range going on, right? And the other range was 8. I've got almost double on the range. Let's look at my sigma. My standard deviation for this one is 5.93. So I've got to square that. So 5, oh, it's a second quit. Clear. 5 point, no, come on, second quit. Delete. Oh, yeah. What the hell? There we go. 5.93, and then I'm going to square it. And I wind up with 35.1649. Okay. But notice this is just a measure of spread. If I had no idea what this data said, and I had these two classes, and you come to me and you said, hey, one class's height was 57 inches. The other class's height is 58.2. I'll go, okay, well, class B is a little taller, right? But then I tell you, hey, the variance for the first class was 9. And then the variance for the other class was 35.16. That tells me that the heights from class B are going to be more all over the place. What that probably means for class B is that the lower and upper heights are more extreme than class A, right? This is a tighter variance, okay? Tighter variances mean the data is going to be grouped together more, where spread out variances means the data is going to be just spread out more. Okay, that's all that means. It's just a kind of a numerical way to show it. But again, we're going to use this later on for other equations that we have. Okay.
Okay, I am having a hard time getting onto that for the L2 when I go to stat.
Oh, you mean like to edit L2?
No, I go to get the class B because we have both of them in there in L1 and L2.
Yeah.
I go to calc and
Okay.
then we still go to one variance, right?
Yep.
Okay, I hit that and it comes up L1, list L1.
Okay. Yeah. So delete L1 out of there. And
Okay.
then hit second stat.
Second stat.
And then go over to L2. And
Okay.
then hit enter. Did it bring it
Okay.
up? Yeah. And then hit enter
Yeah.
again. Make sure you get the same numbers that I got.
Okay, 58.2. And yep.
All right. Then your book on page 118 goes over standard deviation, which in my opinion should have gone over first. But to get the standard deviation, you just take the square root of the variance. It's not a big deal. Your book says there is a problem with using the variance as a measure of spread because the variance is computed for using squared deviations. The unit of the variance are the squared units of the data. So you do wind up with a weird, like we're talking about inches here. If we were going to put units on this would be 9 inches squared would be the unit. So this would be 9 inches squared would be the unit on here. Where the standard deviation just makes it where we don't have squared units. So like for this one, we know the standard deviation is right there because remember we had to square it to get the variance. So the sample standard deviation would be 3 inches. You don't have to worry about, it's kind of just easier to understand because you don't have to worry about squaring the unit. It's a more linear unit where it's not an area unit. So over here it would be, 5.93 inches would be the standard deviation. And what that means is it's just the average deviation from the mean. Okay, so think about this. The standard deviation in a way is easier to kind of grasp. This is the average deviation from the mean. So if I look at this data, the average deviation is 3 inches, where over here, the average deviation is 59.3. That tells me that this data is more spread out, right? Because the average deviation is larger than over here, okay? That's what that's saying. And then the book goes over, hey, standard deviation is not resistant, right? Because it's based on the mean. Since it's based on the mean, it's not resistant. That means we can have an outlier can really affect it, and it does affect it. Yeah, your book goes over a lot of other stuff. It goes over like approximating. I'm not worried about you approximating these because we have a calculator that gets the exact number, okay? So there's no real point in doing approximation when we have a calculator that'll pop out the real answer. Okay. Hold on. Just 1 second, guys. Okay, good. I'm going to stop right here. This is a good stopping point because the second part of this lecture on Monday is going to be over actually some more fun stuff, the empirical rule and other things like that. But this really kind of stops with calculating spread. So I'm going to just get a real picky and choosy in 3.2 for homework. on that you need to get done. And really you need to get this done because it'll make the next what we're about to go over a lot easier, and really understand how to put this stuff in a calculator, because we're going to just use the data off the calculator to kind of draw these assumptions on the population or the sample. So where does I'm trying to see where the check your understanding stuff works. 3.2. See number 1. Oh, there it is. Yeah. So it starts on page 116. At the very top left, you'll see number 1. Okay. And then on page 117, at the very bottom right, you see 2 and 3. And then page 19 or 119, we've got 4 and 5. And then I'm going to skip over the homework and just kind of go over what we've done today. So page 126, if all data sets, so 11, this is real picky and choosy because we haven't gone over the second part of 3.2. So 11 and 12, 15, 16, found the simple variance. 19 through 24. 29 through, it's kind of nice when they just give you the, like if you look in the homework, they give you the TI-84 output and you have to just answer it. So it's kind of easy. 29 through actually just 29 and 30, because the rest of the questions bring up the stuff we're going to go over tomorrow. And then for the like the real world kind of stuff, let's do 35. Amazon taking over. 38. $42. And then let's do we'll stop right there. Okay. So that's for 3.2. It's really not that much. I just had to kind of break it apart